Alright, so we have this interval, or this integral. So we have this integral of g of x dx from 6 to 18, and we have a table of g of x values for certain x values between 6 and 18. And we're told that we need to make a Riemann sum approximation, a right endpoint Riemann sum approximation with 4 equal subintervals. So the first thing we're going to do is write down the equations we're going to use. So from 6 to 18, g of x dx is equal to R4. That's going to be I equals 1 to 4, so that's just saying that we're going to have a Riemann sum approximation, and this is the sum from 1 to 4 of f of ci times delta x. So our R4 is what we're going to find next. So we're told that there's 4 equal subintervals, and we can split this up into 4 groups. They're going to be here, 6 to 9, 9 to 12, 12 to 15, and 15 to 18. And actually what we want to do before we find R4 is find our delta x right here. Then delta x is going to be equal to b minus a over n. And this is going to be our b, 18, the higher value in our integral from where we're evaluating it from. A is our lower one, which is 6, not 0. Sorry, I keep writing 0. And then our n is the number of subintervals, so that's 4. It's going to be, which is equal to 3. And if you notice, these subintervals that we chose just a second ago, 6 to 9, 9 to 12, 12 to 15, and 15 to 18, the change in x for each one of those is 3. So we're doing good. We have our subintervals. And because this is a right endpoint, when we go to evaluate R4 using this, sorry, this is supposed to be G. So when we evaluate this, for the x values we're going to use as C of I, we're going to use the ones on the right of each interval, meaning 6, 9, 12, and 15. So G of 6 plus G of 9 plus G of 12 plus G of 15. And that's this part right here, this sum. So when I equals 1, it's going to be G of 6. When I equals 2 is G of 9, and so on. And then our delta x is 3. So this is going to be equal to 0 minus 2 plus 3 plus 5 times 3. That's going to be equal to 6 times 3, which is 18, and that's going to be our answer.